Okay, so today we are on lesson 3, comparing quantities with percent. It is page S13 in your workbook. If you aren't there yet, go ahead and pause and get there now and play when you are ready. So the opening exercise, please try this on your own first. Pause, try it on your own, and then click play when you're ready. So the opening exercise says, if each 10 by 10 unit square represents one whole, then what percent is represented by the shaded region? So that's this part and this little part over here. So each square represents 1. There are 125. So that's 100% plus 25%, which is 125%. Right, or sorry, this is 1%. This is one whole. That's 125%. Okay, and it says in the model above, 25% represents 10 students. How many students does the shaded region represent? So our equation, or our formula, if you remember, is part equals the percent times our whole. And we're actually going to use a different word starting today. We're going to actually use quantity, because sometimes what we're looking for isn't actually a part of the whole. We're still using a whole. So we're going to see that as we move forward. So the quantity that they're talking about is the percent times whatever whole that we have defined. So in this case, we have our quantity, which is, so first of all, which is our whole. We don't know how many whole students there are, but we do know that the quantity that we know is 10 students, and that the percent is 25. So we have that our quantity equals our whole times percent. So we have 10 equals, we're going to use W, times 25%. 10 equals 25% is a decimal. Remember, we can't multiply with percent, so we need to turn it into a decimal. Times W, and then we're dividing. So 10 divided by 0.25, and we're going to get 10 divided by 0.25, put that in a calculator, and you're going to get 50. So our total is 50 students. So I'm just going to put a note up here, percent, change to decimal form when you're multiplying. Okay, we are going to do this example. We're going to go nice and slow. We're going to add a couple of concepts, but really we're just using this formula to make sense of percents. So the members of club are making friendship bracelets, how cute, to sell to raise money. Anna and Emily made 54 bracelets over the weekend. They need to produce 300 bracelets by the end of the week. What percent of the bracelets were they able to produce, so that they did produce over the weekend? So we're going to start by defining our whole, by defining our quantity. Quantity just means an amount. And defining our percent. So the whole is, our whole is the 300. And the amount that they made is 54. And the percent we don't know. So what you're going to find as we move forward, and these might get a little more complicated, is that the part that's after the of, so in this case the bracelets, that's going to always be your whole. In this case, it makes pretty clear sense, but moving forward, it might get a little tricky. So whenever it says what percent of something, that something is going to be your whole. So we're going to use our formula. Our formula is quantity equals percent times whole. I'm going to abbreviate that. So we have 54 equals our percent times our whole. Now we remember one-step equations. If these two are multiplying, how do we find that variable? We divide. And maybe in previous grades you would just look at this and know you're going to divide. We're adding this, you can divide on both sides because we are becoming familiar with algebraic expressions. So this becomes 1, and we get that P equals 54 over 300. Stick that in your calculator, and you get 0.18. And remember, we're looking for a percent, and this is in decimal form, so it's going to become 18%. So they made 18% of their bracelets. Again, we used our formula, the quantity or the part equals the percent times the whole. We plugged it in, our quantity equals our percent times our whole. We divided, and we got that our percent is 54 over 300. You can see here that the percent equals the quantity over the whole. So we're seeing how that equation can be manipulated. Okay, we're going to go on to the next part. And the next part is still using the same equation. It's just asking us another step. So Anna produced 32 of the 54 bracelets produced by Anna and Emily. Write the number of bracelets that Emily produced as a percent of those that Anna produced. So first of all, let's take a step back and make sure we know how many bracelets each girl produced. So we know that Anna did 32. There were 54 total, so Emily had to have done the rest, which is 22. Okay, so that way we have that out of the way. We know exactly how many each girl produced. So it's asking us to write the number of bracelets that Emily produced as a percent of those that Anna produced. So what this is telling us is that as a percent of is telling us that this is the whole. So whatever Anna did is the whole. It's asking us to compare how much Emily did compared to Anna. So our whole is going to be Anna. And really, some of the most difficult part is actually just deciding and understanding which parts are which parts of your equation. So Anna, which is 32, and then the quantity that we are comparing is Emily, who made 22. 22. And then we're looking for the percent. So percent, we don't know, but we have an equation that we can use to solve. So our equation is the quantity equals our percent times our whole. So we plug in our numbers, and we get that 22, which is our quantity, equals percent times 32. We know to divide by 32 on both sides, and we get that P equals 22 over 32, which, if you plug that into your calculator, will give you 0.6875, which as a percent becomes 68.75%. So compared to Anna, Emily produced 68.75%. Okay, we're going to keep going, keep practicing. Write the number of bracelets that Anna produced as a percent of those that Emily produced. So now we're doing the same thing, we're just switching them. So here our whole is now Emily, who made 22. And our quantity, or our part, is what Anna produced. Here's a case in which part is not really the right word to use here, since Anna's is not really a part of Emily's. It's the quantity that we're searching for, or that we want to identify the percent of. And percent we don't know still. So now we're plugging in our equation, Q equals percent times whole, and we get Anna's, which is our quantity, equals our percent times Emily's. We need to find out what P is, so we're going to divide by 22. That makes a 1, and we get that P equals 32 over 22, which, if we plug that into our equation, into our calculator, we're going to get 1, and then the 45 is repeating. Turn that into a percent, we get 145.45 repeating percent. So compared to Emily, Anna produced 145%. And I just rounded that. So what that tells us is that Anna had more than Emily, which makes sense. Anna had 32, Emily had 22. It makes sense that this is more than 100% because Anna made more than Emily. Okay, so there are quite a few more of these. What I'm going to do first is I'm just going to help to articulate which of them are going to be your whole, and then I'll come back and do exercise 1. So for exercise 1, it says there are 750 students in 7th grade and 625 students in 8th grade at Kent Middle School. What percent is the 7th grade class of the 8th grade class at Kent Middle School? So that of right there, it doesn't say percent. Well, it does. It says what percent of right there. So the part following the of is going to be our whole, which means the other part is going to be our quantity. So our whole is 8th grade, our quantity is 7th grade, and our percent is unknown. Okay, for exercise 2, we're going to do the same thing, and I already have this written, so I'm going to cover this up a little bit. So at Kent Middle School, there are 104 students in band and 80 students in choir. What percent of the number of students in choir, so that's telling us that choir is our whole, is the number of students in band? So our whole, because it says of the number of students in choir, our whole is choir, our quantity is band. So our whole is going to be 80, our quantity is going to be band, and we're solving for the percent. For the next one, at Kent Middle School, breakfast costs $1.25 and lunch costs $3.75. What percent of the cost of lunch, right there we have our whole, is the cost of breakfast? Breakfast is our quantity, right there. And lastly, we have an extra credit problem. So you are going back and doing 1, 2, and 3. If you're ready to do that, please go do that now. If you would like some more guidance, I'm going to do number 1 right now. Okay, so we have identified our whole and we've identified our quantity. I'm going to read through that one more time. There are 750 students in 7th grade and 625 students in 8th grade. What percent is the 7th grade class of the 8th grade class? Since it says of the 8th grade class, it's asking me to compare to the 8th grade class, so I know that's going to be my whole. So it's asking for the percent, we're solving for the percent. Our formula is our quantity equals our percent times our whole. So our quantity is 750 students equals our percent times 625 students. We want to solve for P, which is percent. We're going to divide by 625. That makes a 1, and we're left with P equals 750 over 625. I'm going to write this over here. We get P equals 750 over 625, and we get 1.2. Now, this may make us think, oh, that's 1.2%. That's a really small percent. Now let's think back. It's asking us what percent of this, what percent of this is our whole right here, is this. This number is bigger than 625. So that percent should be really, really, really big. And it is, because we haven't changed it to a percent yet. This is actually 120%, right? From a decimal to a percent, we move the decimal, boom, boom, 2 times. So we get 120%. The 7th grade is compared to the 8th grade. Letter B says the principal will have to increase the number of 8th grade teachers next year if the 7th grade enrollment exceeds 110% of the current 8th grade enrollment. Will she need to increase the number of teachers? Explain your reasoning. So we got the percent of the 7th graders compared to the 8th graders. You can go ahead and answer this question in a complete sentence. And again, you are doing numbers 2 and 3 on your own. And once you finish that, please go and start your exit ticket, which is due tomorrow in class. If you finish that, you can go work on Khan Academy. Awesome.